So when we factor something like this, if I sort of look through all my different factoring methods, common factoring, unfortunately I can't common factor anything here because the 30 doesn't have an x, there's nothing else common. I can't do trinomial factoring here because I have more than 3 terms, of course. Grouping is not possible. I have 5 terms. I can't have 2 equal groups to factor by grouping because I have an unequal number of terms. I have an odd number of terms. So the only option here really is to go through that process that we did for number 3 in our homework, which is we need to set up a list of possible factors by listing out all the factors of the constant. And this is for when our leading coefficient is equal to 1. We can do this. Okay, so all the different possible factors of 30. If I'm not sure what those are, I'm going to write 30 over here, and I'll start just writing out all the things that multiply to 30. So does 1 go into 30? Yes. So I can have 1 times 30 or negative 1 times negative 30. So I've got plus minus 1, plus minus 30. Does 2 go into 30? Yes. 15, right? 2 times 15. So I can have 2 times 15, negative 2 times negative 15. So we'll add those in. How about 3? Yes, 3 times 10. So 3 and 10, and negative 3 and negative 10. 4? 5? Yep, 5 times 6. And we've just gotten to 2 numbers that are very close to one another, so that's pretty much it, right? Because the next one I would ask about is 6, and we've already got that. So there's all of them. So that's always the first thing, possible factors. Second thing, test. All right, I'm going to try 1, because I actually think that might work for us. You usually will find it pretty quickly. It's odd that you would have to test like a bunch of different ones before you find it. If this number is bigger, sometimes there's more factors and sometimes you have to test more things. But I think we get 1 plus 1. Oh no, maybe not. Maybe I'm thinking negative 1 here. 1 plus 1 minus 19, so negative 17. This isn't going to give us 0. What do we get for this one? Okay, 24. Therefore, x minus 1 is not a factor. But perhaps negative 1 might work for us. So these will cancel each other, and then I have negative 19 minus 11 plus 30. That's 0. Therefore, x plus 1 is a factor. All right, so that's good. We'll go into our division. I am using this value in my synthetic division because the binomial is x plus 1. So just be mindful about that. That's a common mistake there. People will put positive 1. And then 1, 1, negative 19, 11, 30. Okay, we will add and multiply.
Would you also know, though, if you put 1, you would get remainder 0? Right?
Yeah, so if you happen to accidentally make that mistake, then you won't get the proper remainder, and then you should be tipped off that that's not right. So yeah, good point. Okay, let's do our synthetic division before we go, and then we'll finish it up when we get back. So drop the first term, multiply, write the answer up here. Add, multiply again, we're going to write the answer up here. So negative 1 times 0 is 0. Add, multiply, negative 1 times negative 19, write the answer up here. 19, add, we're going to get 30. Negative 1 times 30, negative 30, add, we get 0. That's what we wanted. That's good. That gives me some indication that we did this correctly, right? So that will be remainder, constant, x term, x squared term, x cubed term. Okay, we'll hold it there. Did you have a question? Okay, we'll continue when we get back here. We're going to now get this into factored form. So final step for right now is factored form. So I started with a quartic. I'm going to end up probably, because I had a linear divisor, I'm going to end up with a cubic, right, times a linear divisor. So it will be x plus 1 times 1x cubed, so just x cubed, minus 19x plus 30. Okay, when I multiply something linear by something degree 3, I get back the quartic. Right? That should make sense. I should get back what I started with. I'm not changing the degree. I'm just changing the format. I'm just making it into factored form. Okay, this. I need to get this factored if I want this fully factored. So I'm going to look for a common factor. I don't have one. I'm going to look to see if I can factor by grouping. I only have 3 terms. Can't do that. I'm going to look to see if I can do trinomial factoring, which I can't do with a cubic. I'm going to look for sum and difference of cubes, which this is not because it's 3 terms. So my only option is to do this process one more time, right? Don't sigh. All right, so I am now going to factor this. Let's call this maybe f at x. And I just want to factor this cubic here. And it just so happens that the constant is the same as what I had above. So the possible factors list is actually the exact same. So we're going to go through this process, possible factors. I will get those possible factors from 30. So I'm going to get plus minus 1, 2, 3, 5, 6, 10, 15, and 30, same as what I had in the list above. So there's no thinking involved in that because the constant is the same as what I had up there. That doesn't always happen, but it may happen if the factor that you find is 1 from above. Second thing, we're going to do some tests. So as far as tests, I'm already seeing that 1 and negative 1 are not going to produce 0 here. Perhaps we can try, I don't think 2 is going to do it. 2 actually might do it for us. Let's try 2, f at 2. Because we'll get 8 here, and then 19 times 2 is 38. So I'll get negative 38 plus 30. So I think that's going to do it for us. Okay, 1 and negative 1, you could probably just look at it and predict, like, oh, I don't think that that's going to add to negative 30 together, right? So therefore, x minus 2 is a factor. Okay, there's also a way, guys, in your calculator that you can actually sub in the equation using x variables, and you can evaluate it for a bunch of different x's. So that might be helpful for your tests. Everyone's calculator is different, so either look up a YouTube video on it, or if you're curious about how to do that, I might be able to help you for your calculator if I take a look at it. Okay, we're going to go into our third step, which is to divide, now that we have our factor. And by the end of this unit, hopefully we are very comfortable with synthetic division, right? Because we're doing it a lot. So I'm going to use 2 here. I'm using f at x, so I'm going to have 1, 0, negative 19, and 30. Why did I put 0 there? Lexi? Okay, I don't have an x squared term in between x cubed and x. I must have that placeholder in synthetic division, right? If I don't have that, that's going to actually give me the wrong answer. So be mindful about that. You should know if you're getting the wrong answer here because I won't get a remainder of 0 if I forgot to put that placeholder. So make sure you put that, make sure you get a remainder of 0 at the end of your division. So drop the first term. 2 times 1, answer goes up here. It'll be 2. Add that column. 0 plus 2, that's 2. Multiply. 2 times 2, answer goes up, 4. Add, get negative 15. And one more time, multiply. 2 times negative 15 is negative 30. And we add. If you've done it right, the remainder should equal 0 because we already calculated it up here. If I actually found a factor, the remainder must be 0. So there's our remainder, our constant, our x term, and our x squared term. We're going to continue the factoring above. Now that we have this. And don't forget about this. This is another bracket that we just found. So here we go. Now we're factoring further. X plus 1 will stay as it is. I just divided into f at x, or this here, with x minus 2. I'm going to put that here. And then I'm going to put the remaining quadratic that I had from down here, which is x squared plus 2x minus 15. Okay, so divisor times quotient from my division from below. We're almost there. Can we factor any further? Oscar?
You need to find numbers that multiply negative 15, add to positive 2, so that's going to be 5 and negative 3.
Good. Easy factoring right into the brackets, right? So x plus 5, x minus 3. And this is now fully factored. I don't think this one says to state the solutions. It just says fully factor. Yes. Question, Lexi? No? Any questions? So I started with a quartic. Did I end with a factored quartic? Does this all add up to degree 4? So I have 4 zeros and they're all order 1. So this is still a quartic, right? That needs to be a check that you ask yourself at the end, because if I factored something that started as a quartic and then I end up with something here that's a cubic, I've missed a binomial somewhere, right? I've missed one of the solutions somewhere along the way. Probably either here or here, I missed putting one of those in, right? So I always need to make sure that I include those divisors in my factoring. And I always need to make sure, obviously, that my degree is still the same as what I started with. That's the point, right? I want to factor the quartic, and I want to make sure I get a quartic out of that. Okay, we have one small theorem. This is our last theorem of this unit at the beginning of lesson 4.